Hi class, so we're going to start the second half of the polynomials unit. The first half we talked about powers and exponent laws, and now we're going to talk about algebraic expressions and get into what the word polynomial actually means. So the goal for this lesson is kind of an introductory lesson to polynomials, and I want to teach you terminology. So this slide has a list of all the terminology that I would like you to know, starting with the word variable. Which I talked about in lesson 1 of the unit, actually. I'm just going to repeat it here. So in math, we sometimes use letters. And when we use letters in math, some of the times they represent what we call variables, which is what we're talking about today. But other times they represent unknowns, which we talk more about in Unit 3 when we do equations. Okay, so we're going to stick with using letters to represent variables for today. And the word variable means able to change. Okay, a variable means able to change. So if we have a quantity, sometimes since the number can change all the time, we don't want to write the number down for the quantity. Sometimes we use a letter to represent it, like the letter X, or it can be any letter really. For example, we can use the letter T to represent the temperature outside, and that's a variable because the temperature outside is always changing. Like right now it's 17 degrees Celsius, but closer to noon it was more like 24 degrees Celsius. So we use a letter to kind of hold the place of that quantity, and we call that a variable. Okay, so that's the first term, variable. Next, we're going to go with a monomial, and I'll start the next slide for that. So monomial, that's going to have the definition of product of variables with, I'll say, natural number exponents. Or actually, I'll say whole number exponents. Because the exponent's allowed to be 0, actually, for a monomial. So 0 is included in the set of whole numbers. And number. Okay, so that's the definition of it. So to give you some examples, here's what one of the more complicated monomials might look like. 4a squared b cubed. Now, why does this satisfy the definition? Because first of all, it's a product of things. The 4 and the a squared and the b cubed, they are all multiplied together. When we write them beside each other like that, with no operators, it's assumed that the operation is multiplication. Okay, that's what makes it a product. A product means, product refers to multiplication. And the product is of variables. There's two variables there. A and b are both variables, and they have whole number exponents. 2 and 3 are whole numbers. And it's also a product with a number. The number happens to be 4. Now I'm going to go into the next definition, which is called coefficient. And the coefficient is not the most formal language here, but I'm just going to do it anyway. The number part of a monomial. Yeah, that's not really good, but I'm going to run with it. The number part of a monomial. And by the number part, I mean, in the example above, the 4. So the 4 in 4a squared b cubed. Okay, so the number part does not mean the exponents. It means the number that's in front of it all, that's being multiplied to the variables. The number in front is called the coefficient. Okay, we'll do another example of a polynomial. Let's say x y to the 6. Okay, so there's another example of a monomial. It's a product of variables. All the exponents are whole numbers, so the exponent on x is 1, and the exponent on y is 6. And it's also multiplied by a number. Now, you don't see a number in front. However, you can think of there being an 1 that's just not written. We don't normally write 1 times something. So the coefficient in this case is actually 1. So the 1 in x, y to the 6. So sometimes the coefficient is 1 and it's kind of hidden there. The coefficient is allowed to be any real number, really. So I'll do a third example. Even if I say something like 3/4, I'll just use x again, 3/4 x squared. That's another example of a monomial. It's a product of variables. Now, it's allowed to be just a single variable. This time there's only one variable, and it's x. The exponent on it is a whole number, 2. And it's also multiplied by a number, 3/4. So in this case, the coefficient would be 3/4. So 3/4 in 3/4 x squared. Okay, so that is the definitions for monomial as well as coefficient. Okay, they're kind of tied together. A coefficient is just a part, the number part of a monomial. Okay, so next I will talk about the word degree. Degree. Okay, so the degree, and I'm going to add of a monomial. Degree of a monomial. So this is one example of what we call a property of a monomial. So most nouns, like person, places, or things, they all have various properties. For example, color is a property of any object. Like my hair is black, that's a property of my hair. Well, monomial are things, they're mathematical things, so we should be able to describe them with various properties as well. One of those properties is the coefficient. Another of them might be how many variables are involved, that's a property. But a very important property of a monomial is called its degree, and that is defined as the highest no, sorry, that's wrong. The sum of the exponents on the variables of a monomial. The sum of the exponents on the variables of a monomial. So I'll use the same 3 examples in those 3 colors. So for example, for the first one, 4a squared b cubed, if I add the exponents on the variables, so I would add 2 and 3, 2 plus 3, that adds to 5. So we call the degree of this monomial 5. It just has a degree of 5. It gives kind of an idea of the size of the exponents of a monomial, but you do have to add them all together to get the final degree. So the green one is xy to the 6. And in this case, we add the 6. Also with the 1, don't forget the exponent on just x is 1. So 1 plus 6 is 7, so the degree of this one is 7. And then the yellow one, 3/4 x squared. Now this one, there's only one exponent. There's only one variable, so it's simpler. The degree is simply 2. the exponent on the lone variable. Okay, so that's the term degree of a monomial. Okay, the next word on the list is constant. Constant. So a constant is, it counts as a monomial. It's a very special example of a monomial. It's a monomial with no variables. So basically, it's just a number, basically, by itself. So an example of a monomial would simply be just any number. I can say the number 10 is a constant. Okay, so we can talk about the same properties of even constant. So what's the degree? The degree of this. So the degree is the sum of the exponents on the variables. But that's nothing. That's zero. There are no variables, so there are no exponents to any variables. So they all add up to 0. So that's something else I'll write that's special about constants. The degree of a constant is 0. Because there are no exponents on variables. Okay, good. So just one more example to kind of put it all together. Let's say negative 6. I'll use A's and B's and C's. A squared, B 5, and I'll say C. So if you take all this and apply all of the terms we just used, this is a monomial. Okay, so this is a monomial. Okay, it satisfies the definition of monomial, a product of variables. All the exponents on the variables are whole numbers. Okay, there's also a number multiplied to it. So the number part is called the coefficient. So the coefficient is negative 6. The degree is, you have to add up all the exponents. So the degree is 2 plus 5 plus 1. The C has an exponent of 1 on it. And so the degree is 8. And it's also not a constant. This is a monomial that is not one of the special ones called a constant. Okay, good. We're doing well. Next terminologies. So a polynomial. Now we will get into polynomial, which is the title of this unit. We finally talk about the title of the unit. So a polynomial is simply an expression containing at least one monomial No, I'm going to change the wording on this. An expression that is either a single monomial or multiple monomials added together. They can also be subtracted, but I'm just going to use the word added. Okay, so as an example, I can just use one of the polynomials from above. I'll just say 4x squared. So that's a monomial. Now, a monomial by itself, it counts as a polynomial, but if I add an extra term to it, so if I say plus, let's say 6, and I'll say xy cubed, now I have two monomials, and they're added together. So now I can't call the whole thing a monomial, but I am allowed to call it a polynomial. Okay, so when you have two or more of them and they're added together, then we can start calling them polynomials. There can also be a minus sign. I'll just say x squared y. Minus sign, it pretty much counts as adding as well. It's just like adding a negative. Okay, so now I've got three monomials added together. So this still counts as a polynomial. Now, when we count how many monomials there are, well, in this case, there's three of them. So each of the three monomials, we call them terms. I guess that's just a shorter way of saying a monomial. So the word term is one of the monomials in a polynomial. Okay, and a little trick, sometimes they ask you to count how many terms there are, and you can usually do that by seeing how many pluses and minus signs there are. The pluses and minus signs, every time there's a plus or a minus sign, it indicates a new term is going to be written down. So I'm just going to write terms can be identified by plus and minus signs. Okay, so in the example above, so in the polynomial, I'll copy the same one down, 4x squared plus 6xy cubed minus x squared y. There are three terms. Yeah, there are three terms. And I will list them out. One term is 4x squared. The second term is positive 6xy cubed. And the third term is negative x squared y. So the sign is part of the term. So if it's a minus sign, the term is considered a negative. All right, so that's all a polynomial is. It's when you have one, but you can have more monomials added together. And each one of them is called a term. So if there is one term, just one term, we call it a monomial, as we already did. So mono is a prefix that stands for one. You might have known that from like other things that start with mono, okay? Like a monologue is one person talking. A monomial is a polynomial with one term. Binomial is a polynomial with two terms. And a trinomial is a polynomial with three terms. So the example we have here is actually called a trinomial because it has three terms. And so I'll write those down on the next slide. A binomial and trinomial. So a polynomial with two terms And a trinomial is a polynomial with 3 terms. So I'll give an example of each. An example of a binomial can just be a plus b. Simple as that. A plus b. A is a monomial. B is a monomial. So there's 2 of them added together. That's called a binomial. And for a trinomial, I'll give you an example of what you might see a lot of next year in grade 10. Something like this, x squared plus 5y plus 4. So that's an example of a trinomial. It's got 3 terms. X squared is 1 term, positive 5y is the 2nd term, and positive 4 is the 3rd term. That term is called a constant. All right. Finally, we're going to talk about the word degree again, but now we're going to apply it to polynomials. Degree of a polynomial. So we've already talked about the degree of a monomial. That's when you add all the exponents together on the variables of a monomial. What if it's a polynomial? So there could be more than one monomials in there. So if you guess, you just add all the exponents on all the terms, you would actually be wrong. That's not going to be the definition of the degree of a polynomial. I'm going to write out what the definition is going to be. It's going to be the highest degree of the monomials within a polynomial. So it's not all of the degrees added together, it's the highest one. So I'll give an example. Okay, let's say we have 5 a squared b plus 7 b to the 4 minus 3 a cubed b squared. Okay, let's say that's a polynomial. Just to review some terminology, this is a polynomial because it has 3 monomials. The coefficients are positive 5 for the first term, positive 7 for the second term, negative 3 for the third term. The variables here are a and b. And this is a trinomial because there are 3 terms. Okay, so each one of these terms, I'm going to look at its degree. So for the first term, the degree of this term is 2 plus 1, which is 3. Okay, a squared and then b to the 1. They add up to a degree of 3. The second term by itself has a degree of 4. There's only one variable there, b, and it has exponent 4. In the third term, and notice how I made sure the negative sign was underlined because the sign is included as part of the term. The third term has a degree of 3 plus 2, which is 5. So the degree of the whole polynomial is going to be the largest one of these, which is 5. Okay, so the degree of the whole polynomial is 5. Okay, so that's the degree of the polynomial. All right. So that's the terminology. There is one more thing that you may have to do for part of your homework, and that's to match algebraic expressions with words. Okay, so I'll just say one skill you will need to acquire is to, I'll say, create an algebraic expression. To represent a situation or word description. Okay, so we'll start with some simple examples. Okay, so let's see. If H represents how many hours you worked, and I'll say $15 an hour is your hourly wage. Write an expression for your total pay. Okay, write an expression for your total pay. So your total pay, you'd have to take the situation and write an algebraic expression to represent that total pay. So you may know that you simply multiply your hourly wage by how many hours you worked. So that would be $15 an hour multiplied by how many hours you worked, which is represented by the letter H. So it'll be 15 times H, or just 15H. Okay, so that's what we're doing, but they will get a bit more complicated. So let's see. Geometry is usually a place where you'll see a lot of algebraic expressions. So I'm going to draw a shape here. So this shape is a square. And on top of the square is going to be a half a circle. And on top of the square is going to be a half a circle. Okay, so I'm going to use these tick marks to represent that the sides of the square are all equal. All right. So I'll say if the length of the square is x, write algebraic expressions for the perimeter and area of the figure. Okay, so x will be the length of all the sides of this square. And notice that x is also equal to the diameter of the circle. That's going to be important here. Diameter is the length across the middle of the circle. Okay, so for this one, the perimeter, you do need to have some background knowledge of geometry, actually. But perimeter represents the total length of the outside of the shape. So I'm just going to use a highlighter to go over that. The perimeter would be one side, two sides, three sides of the square. and then the semicircle. Okay, so 3 sides of the square and the semicircle. So the 3 sides of the square, the perimeter would be x plus x plus x. That's written as 3x, 3 times x. But that's not the whole perimeter. We have to add the length of the semicircle. So maybe you heard of the word circumference before. And circumference is equal to the number pi times the diameter of the circle. So in this case, it would be pi times x, because x is the diameter of the circle. Now that's the circumference of an entire circle, but here you only have half of a circle. So I'm going to add towards the coefficient here, multiplying by half. Okay, so this would actually be a binomial that represents the perimeter of that shape. The binomial has 2 terms. The coefficient of the first term is 3. Coefficient of the second term is half pi, actually is an interesting coefficient. And the degree would be 1. Yeah, x has an exponent of 1. Okay, and then if we do area, area is the space inside the shape. So the area of a square is length times width, or in this case it's x times x, but x times x is represented as x squared. And we have to add it to the area of the half a circle. So I don't know if you remember from geometry, but the area of a full circle is pi times the radius squared. So pi times the radius is half of x squared. And that's for a full circle. For a half circle, it's multiplied by another half. Okay, so that one might be more confusing. You know what, don't worry too much about these geometry ones, because we will have a geometry unit later on in the year. Okay, but anyways, you will have to kind of get creative with making equations. You have to kind of use your intuition in terms of when to add, subtract, multiply, and divide to build these equations. It's just that instead of throwing all numbers into these expressions, we are now going to throw some variables in there. And the main goal is actually to be able to talk about these variables using the right language. Okay, like coefficients, degrees, polynomials, and all of that. Okay, so that's an intro to polynomial terminology.